Everyone, welcome back to Dr. Spurt. Today we continue to analyze and design steel building by using Tekla Structural Designer latest version 2022. Now let's start. Click on Create New Project. After Create New Project, you can create construction wall, or you can create a construction grid line for modeling. Now let's start from the construction wall. At the base, you can insert a bow. Now let me insert 3.2 meter. And continue to insert a bow. The number of story is a 15-story building, and the source you can select it's similar with the top, or you can do it similar with the which one story. Yeah, let's say you can select similar with the story 14. Now let me click and do the same similar story with the story 15, the last top story. Okay, click to change to 15. So when you model on the story 10 or 9, it's the same with the story 15. All the story will be modeled as same. Okay, now let me change to 15 and 15 again. Okay, click OK. Click on grid. To create grid, you can create a shader wizard as or import from the S file. Now let's start from the rectangular wizard. Yes, continue next, and the origin of the grid is 00. Global coordinate system. Click on next, and all line we use the dash dot line. You can change it to irregular length. Now let me type 2 multiply with 6 meter, comma, and 7, comma, and 2 multiply with 6.5 meter. Okay, the grid line, the base 2 6 meter 1 2, and the base spacing is 6 meter 7 meter, and the last two base is 6.5 meter. Okay, now let's continue to the Y direction. Click on it. You can change for the name grid by the alphanumeric. This one for the number. Now let's change to irregular length. Let me type to 3 multiply with 6 meter, and comma 5 meter, comma, sorry, this one is comma, not, yes, this one, comma, okay, comma, and 3 multiply with 7 meter. Okay, this is the grid line of our structural steel building. Now click on it and orientation 0. Need click on finish. Okay, can we use on 3D to view the grid, or you can turn off grid, architectural grid. Okay, now come back to the, let me click on this for the structure, and structure you can expand for the wall, architectural grid, yes, and substructure. You can tick and untick it. Now let's click on the last top story. Okay, and let me there for the column. This is the steel column. You can use plate, concrete fill, concrete, and cast it. Now let's click on the column. We model from the base to the top story, top building. Yes, and the characteristic use the column and the material is still fabrication roll. Yes, you can change it to a plate or to other fabrication. It is the hot roll section, and the strength now let me change to 255 because this strength is available in my local area. In your local area is available high strength, you can design it for the 355 or 275 for the zero code user. Now let me use the low class S235 for the gear strength of the elements. For the beam and for column we use the same. Yes, when you use the lower strength, so the section will require larger than high strength of the steel. There we use auto option design and column. You can change the column. Yes, add new, edit. Now let me change the section. Add new. You can add the section. Okay, you edge section. Now let me use edge section, and the edge section 600, edge section 500. You can select edge section and you can add. Yeah, now add the section, add it manually, or you can click on console. And now let me come back to the U design. Yes, this one is designed, and now let me import other section. Yes, you can import head for the other section. I beam, H beam. Now let me click head. Yes, you can add all and change the name. Now let me use the standard section or the pretty standard UC universal column. Change it to 400. You can use a universal beam for the larger bending. Now let me start from this section. Okay, and select. Okay, so when the design is not passed, the software will be automatically update this section. A400 multiplied with 400 and multiplied with 415 kilogram per meter length. And for the release width, structural strength, eccentricity, you can include eccentricity, side constraint, sway and drift. Now let's check all the override 3. Okay, 300, it's okay. Now let model the column. Okay, you can change the column direction. Now let me change the direction of the column. Click all and click on the rotation. Now let's change to 90 degree. Okay, all the column will be changed. Come back, click on 3D. Yeah, we on 3D. Come back to the 15th story and click on the beam. Now let me select on the beam, and for the outside at the parameter beam we will model as the steel beam, not a composite beam. Okay, let me select and change the steel grade to 255. This grade is most popular in my local area. And change the section. You can change the section, new. Okay, we use a universal beam, and the section of the outside beam we use 500. Okay, now let's keep 500 and 200 is correct. Click OK, and the alignment top, yes. Now let model at the outside, yeah, this one. We use a non-composite beam for modeling. Yes, and now let's change for the inside of the building, change it to the composite beam. We use the stud, connect with the concrete slab, and the section we keep it the same. Okay, and the measure alignment at the top. Yes, you can change the stud strength, the stud diameter. Okay, we use it in default, the 222 diameter, and the stud height is 125. So you should use the slab thickness over 125. Okay, and apply the NCCI PN connector layout. You can change the connector layout, the min group spacing and the max group spacing. We use auto layout. For the rebar, we use 500. You can change the rebar to 410. It depends on your market, this rebar available or not. You can select available strength for your design project. Now let's come back with the floor construction. You start. Okay, methodic, you can select methodic, start strength. Now let's come back to start strength. Yes, to growth beam, and the specific ultimate tensile 450 megapascal. This is the default or the critic. Start strength and start height, start diameter, we keep the default. Yes, the rebar strength for the slab. You can use out of length, prevent out of length. Now let me select all. One, two, three. You can select it all. Now I want to select it one grid by one grid to show you how you can model it one by one. You can model it in the whole layout. Now let me check it. Okay, let's check what is the difference of the color. This one for the non-composite beam, and this one, the yellow color, is for the composite beam. You can click on the 3D and let's review about the structure. Okay, it shows different color on the member, and when you take the mouse over the beam will show more information. Composite beam I500 multiplied with 200, and take over the H beam, the section is 500 multiplied with 200, and the beam is designed as the non-composite beam, and for the column also non-composite column. Okay, now everything is okay. Come back to modeling, slab on grade. You can select on slab on beam, and what we have to change now is the slab on beam. you can change it to the composite slab, or you can use the precast. You can design a precast concrete slab or plate slab or composite slab. Now we use the composite slab. Click on the composite slab, and now let's change the thickness. The thickness we use 150 millimeter. Okay, and the concrete class we keep in the default C32 cylinder and 40 megapascal for the cubic strength, and the long-term elastic modulus we use in the default, and the diagram rigid. Now let's check for the, you can apply bonding to the construction stage. Country Singapore. Okay, reference. And type we use mesh. You can change the strength. Mesh type, yes. You can mesh type. This is the tire mesh. Now keep it in default. Come back again. Yes, the class is strength of this mesh is 500. This strength is available in my local area, and bar size you can change the bar size to A6 or A7. Check with the catalog of the product. Okay. Now let me place the composite slab on the steel beam. Okay. Please wait. Okay, this is the direction of the deck. You can check the direction of the deck. You can click on one deck. Now let's check the one deck, and in case you want to change the direction of deck, you can check it. Now let me check where we can change the direction. The composite is correct, and one way. Yes, composite design only one way, not two way. And Singapore mesh type, yes, connectivity. Let me click on edit S1, and the overall thickness composite slab concrete metal deck. This is the default manufacturer. Yes, reference and the gauge reinforcement. Yes, this one is the you can change orientation. Now let me check for this slab is S1. Now let me come back again. Yes, is SL1. Okay, you can click on SL1, and orientation SL1 you can change it to 90 degree. Okay, so the direction of the deck will be changed when you select and change the direction. Now let me keep the default. Okay, Control Z. This is how you can model the composite and change the direction of composite slab. Okay, now after complete for the 3D. Okay, for the 3D modeling for the concrete, for the steel beam, steel column, composite slab. Now let's check the composite slab and connect between slab and the composite. It's okay. Now let me hide the elements. Remember, yes, it's correct. The connect between the composite beam and composite slab. come back to the 3D. Okay, for the steel structure you have to model the pressing. The pressing is very important for the steel structure. So for the stability, for the group wall stability, we have to add pressing. Now let me change the pressing, check on the pressing. We add the pressing. Yes, you can check on the model. You can check this for column, for the beam pressing here. You can use the edge pressing. Now let me choose the edge pressing, and the steel grade I use 235 megapascal, and we use the hollow steel section. Can edit. Yes, hollow steel section, and select the section, add new. Now let me change to 160. Okay, and the thickness is 6 millimeter. Click on select, and the release pin is correct. Compression, effective length 1 tension, side constraint. Yeah, this parameter is very important when you design the pressing. You should check the connection to make sure your connection is correct with the reality or the construction site. Do not model it as the fit connection, but when you install it on the construction site as pin is not correct with the design concept. So everything from the design concept and the construction site is the same by translate from the structural design to the structural plan. So to make sure the concept of design is correct with the construction plan. Now, okay, let me click on the view. You can change to the view, or you can model it to the 3D model directly. Now let me model it directly. Click on 1 and click on 2. Sorry, again 1 2 3. Okay, and press enter. Yes, this is the way you can model in Tekla Structural Designer. Do the same concept. Okay, you can enter. Yes, then model it again and again. Enter. Because the building height we do the same, so you can copy it. Control select, and right click on mouse to rotate the view. Click on edit, copy. Now let's copy from the base floor to this floor. Let's continue again and again. Yes, complete. So now we shall complete for this edge. Again, click on the pressing. You can click on the pressing direct. Now let me click on the whole of this frame, and I click on the copy, edit, and the copy, and untick all. Select on the member. Now let's check me for the member. No, it's not correct. Composite is not correct. Yeah, breast. Okay, this one. Now we select for the breast member only. For the copy, click on the best point you can, and now let's copy to this side, and again. Yes, so we complete for the pressing in the pressing for the X direction. Now let model pressing for the Y direction. Okay, you can check it. Now let's come back again for the pressing. click on the model, it's pressing. You keep everything in the default. You can use 235. Yes, this one is correct. Okay, now let me use this one for the A pressing. Okay, A pressing. You can change it. Click on 1, 2 and set. Okay, for the A pressing. Enter. For the more effective pressing, you can use the it pressing. Okay, it pressing is good, and transfer load from the node to node directly. Yes, when you can use this model, you can keep the it pressing for the stability or the bidding. It depends on the bridge on the location. You can model it's not sometimes because the opening or door or window intersect with the pressing, so you can do other type of the pressing. Now let me do the it pressing. Okay, again come back, it pressing. Yeah, type it pressing. You can change it to the VKA. Okay, and the steel use 235 megapascal. The section we use the same. Click 1, 2, 3. Okay, 1, 2, 3. Enter. 1, 2, 3. Enter. Okay, now escape and select for the pressing. Control. Right click on mouse for the rotation. Hold right click for the rotation of view. Click on edit. Copy again. 1, 2, 3, 4, 5. Okay, now you on the right view. Again click on the pressing. Okay, now let's click on the whole frame. Again on the whole frame. Okay, click on the edit, copy and take all. Click on the press pair. Okay, now press pair. We select only the press pair and click to copy to other side. Yes. Now let's check, because this pen is not the same, so you have to change the node. Yeah, now let's change the node on the right. Let me change node one by one. Okay, yes, you can change it one by one. So it is really hard to change it one by one. I don't want to change it one by one. You can copy it, or you can. Now let me change 2 or 3 floors. After that I will copy it all. Yes, this is how you can edit model directly in the graphic or the Tekla Structural Designer. Escape again. Click on Vim. Click on Node. Let me escape. Click on the home. Again. Now let me delete. Okay. let's save it to a 15 story building composite floor. 15 composite slab. 15 composite building. Now let me call it building, composite building, composite steel building. Okay, let's save.